Now we know that a relation is a partially ordered relation if it is reflexive, antisymmetric and transitive. And then when we take a set and the relation which is partially ordered relation, then we call the combination as a poset, isn't it? Then if the set on which this partial order is defined, if it is finite, okay, everything we are doing here only when it is finite, okay. If it is finite, then a easier way to represent the relation will be using a diagram. The reason why we will be using this diagram is it will make it very easy to answer many questions on that. So very often, instead of talking about the sets as in set representation, we will be trying to draw the diagram which is called as Poset diagram, or it is also named after a person, Hussey, who first, he is not the first one, but then he popularized it. So in most of the derivations and theorems that he has proven, he has used this diagram. That is why it is also called as Hussey diagram or Poset diagram. So one important thing about Poset diagram is it is not essential that you draw the Poset diagram to answer many questions, but if you do it, it will be easy for us to answer the questions. So instead of putting this topic at the end, I am just putting it at the beginning of this topic, and then whatever question I will take up, I will just use the Poset diagram to make the concepts simple. Okay, so this is about the description of how to draw the diagram. What it is saying is, okay, I'll just explain you them point by point. Anyway, with examples it will be more clear. You will not understand anything even if I read it out. Just for the sake of completion, I'm describing you in words, but with lots of examples. I'll do lots of examples in this. It will be very clear for you. Okay, see this. Now, if you have a set capital A and a relation capital R, which is partially ordered relation, then this combination will be called as a poset. Okay, that is, we already know it. Now we try to put them in a diagram form. How do we put it in a diagram form is, we take every element of the set A and we make it as a point or a node in the graph, right? So see this, there is a vertex corresponding to each element of A, which means we take every element of A and we make it a vertex, and then we try to add the edges. Now how do we add the edges is, if there is a relation between element A and element B, we try to add an edge, right? So generally, what are the types of relations that you will see? So one type of relation will be of type A comma A, right? Then what should we do? If we have a point or a vertex with A, then we should put a relation from A to A. But then in Poset diagram, since every node is going to anyway have this reflex relation, why? Because it is a reflexive relation, therefore every node is going to have this loop. So since every node is having it, we simply avoid it. It is what we do is we infer it from the diagram, which means it is implied. That is what the meaning of it. So we will not put any edge which is corresponding to the reflexive relation. Got it? And then second statement is, see this, an edge between the elements A and B is not present in the diagram if there exists an element X such that A is related to X and X is related to B. So in other words, to put it simply, we will not represent any transitive relation. For example, if you have three elements A, B and C, this is A, this is B and this is C, and now in your relation, if you are having the ordered pairs A comma B, then there will be a link or edge from A to B, right? And if you have a relation from like this, if you have ordered pair B comma C, there will be a edge like this. And if you have a relation, a ordered pair A comma C as well, we will not put this link because it is already implied from these two edges. So that is what the meaning of it. The second point says that we are not going to represent any transitive relations. Got it? And the third point says this, an edge between the elements A and B is present if A is related to B and there is no element X such that A is related to R, A is related to X via R and X is related to B. So it means that we are going to have an edge only when there is no transitive relation at all. Okay, so simply put, it is to bring it down to simple points. Let's see a small example. Let us say we have a relation like this, 1 2 3 is the set A, okay, and the relation is less than or equal to, then what will be the elements that will be present in this relation? So the relation will contain definitely 1 is less than or equal to 1, 2 is less than or equal to 2, 3 is less than or equal to 3, then 1 is less than or equal to 2, then 1 is less than or equal to 3, 2 is less than or equal to 3, right? So these 6 elements are going to be present. Anything else? I think that's it. Okay, so these 6 elements 1 2 1 3 2 3, yes, these 6 elements are going to be present in this relation. Now Poset says like this: you just maintain, let's say, so let me say 1 is here, 3 is here, 2 is here, and 1 is here, right? So generally, if you want to represent all these ordered pairs in the graph, you are supposed to represent 1 comma 1, 2 comma 2, 3 comma 3. For that you are supposed to say 1 is related to 1, 2 is related to 2, and 3 is related to 3. But then since we already know that it is Poset, anyway there it is reflexive, which means anyway the diagonal elements are implied, so this need not be present, so you can ignore them. So that is why they ignored these reflexive relations. And then the second point is, when 1 comma 2, which means from 1 to 2 you can have a edge, and then 1 comma 3, from 1 to 3 you can have an edge, but then there is 2 comma 3 already. See this, 1 comma 2 is there, 2 comma 3 is there, and 1 comma 3 is also there, therefore you need not have this. So that is the meaning of it. So if you are already having 1 to 2 and 2 to 3, you need not have this. And also, for the sake of simplicity, we are not going to use the arrows. Instead of arrows, we always use the representation that if a node is present below and if a node is present above, and if there is an edge from below node to above node, we assume that the ordered pair corresponding to that edge is 1 comma 2. In case if you have something like this, if you have 2 here and 1 here, and if you have an edge, then the order pair corresponding to this is 2 comma 1. So why do you think that we are eliminating this transitive relation? Is because we know that it is already transitive. Therefore, if you have an edge from 1 to 2 and 2 to 3, then already 1 to 3 is implied. That is why we are not representing reflexive and transitive relations. We represent only the remaining other kind of relations between the elements. Got it? That is nothing but antisymmetry. And that too, we will not use the arrows. We always use the convention that the elements are related from bottom to top, which means if I have something like this, it means that it is corresponding to the ordered pair 2 comma 1. If I have something like this, AB, then it is then this is corresponding to the ordered pair B comma A. That is what we infer. Okay, so I am not sure whether you understood anything from this definition. So what I will try to do is, I will take some examples and I'll see that you will understand this. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%. But all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.